Objectives: 1. Discover what happens to the weight of an object when it is submerged in water. And 2. Demonstrate Archimedes' principle: any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. The materials necessary for this experiment are 2 or 3 hooked masses or other objects that sink in water between 0.25 and 1 kilogram, an overflow cup, cylinder with a spout, a beaker, 200 milliliters or larger, a 10 Newton spring scale, and a triple beam balance. At this moment, please pause the video and read the procedure aloud. The following slides will show each step as should be performed in this lab. Analysis and application questions. 1. For each object, find the buoyant force, F buoyant. There are 2 ways you can do this. It's either the equation found in column 3, which is the difference in weight of the objects when suspended in water, and in column 6, the weight of the water displaced when the object was placed in the water. We find that the buoyant force in this solution was 0.2 newtons. This should also be placed in your chart. Question 2. For each object, how does the difference in weight when suspended in water compare to the weight of the displaced water? When placed in water, the object experiences an extra force against the force of gravity. This force is called buoyant force. Due to the extra force, the weight appears to be relatively decreasing in comparison to the weight in air. However, this is just the magnitude of the spring force, i.e., the difference between the force of gravity and the buoyant force. 3. Using the expressions in columns 3 and 6, write an equation relating the difference in measured weight of an object in water to the mass of the water displaced. The derivation can be seen below. 4. For an object suspended in water by a spring scale, what forces act on the object? Well, buoyant force, gravity, and the spring scale force upholding it in water. 5. Draw the free body diagram for an object suspended in air and in water as in the diagrams below, identifying all the forces acting on the object. The free body diagrams can be seen below. Please pause this video and write this down in your notebook. 6. 2 objects, A and B, weigh the same in air and both sink in water, but A has a larger volume than B. A. Which of the following 2 will displace more water? A will displace more water due to the more volume the object takes up when submerged in water. And B. Which of the 2 will experience the greater buoyant force? Why? Object A will experience a greater buoyant force because Object A has displaced a larger portion of water in the beaker, as displayed by the equation for buoyant force. For questions 7 and 8, the density of an object, rho, is equal to mass divided by volume. The density of water is 1,000 kilograms per meter cubed, and the buoyant force is equal to the mass of the water times gravity. Question 7. If you know the mass of an object, but not its volume, how could you use this lab to find the object's volume? After we evaluate the magnitude of buoyant force in step 1, we can break apart the buoyant force equation to find the volume displaced. As you can see throughout the evaluation of the equation, the volume displaced will be the volume of the submerged object. Question 8. A 12 kilogram object sinks to the bottom of a pool of water, displacing about 0.004 meters cubed of water. Part A. What is the mass of the displaced water? The mass of the displaced water is equal in magnitude to the mass of the object submerged. Therefore, it would be 12 kilograms. Question B. What is the buoyant force applied to the object? As you can see through the derivation of the buoyant force equation, we get that the buoyant force is 39.2 newtons. Question C. What is the weight of the object? Well, weight is equal to mass times gravity. Therefore, 12 times 9.8 is equal to 117.6 newtons. Question D. What is the apparent weight of the object when it's in water? The buoyant force is pushing up on the object while the force of gravity is pushing down on the object, and the acceleration of the object is equal to 0. Therefore, we can say that the force of buoyancy is equal to the weight apparent. Therefore, the apparent weight is 39.2 newtons. Thank you for your participation in this online lab. I'll see you next time.